Alright, let's start discussing the 21st question. Two identical open pipes, each of length 50 centimeters, are surrounded with their fundamental knots at 15 degrees. So we have two open pipes which are identical and their lengths are 50 centimeters, and also they are at a temperature of 15 degrees. And they are also resonated or sounded with their fundamental knots. The variation of velocity of sound V in air with temperature is given by this equation, where velocity is equal to 331 plus 0.6 theta, where theta is in degrees Celsius. If the temperature of one pipe is raised to 30 degrees, what would be the number of beats produced per sound? Let's see. So what's the equation that gives you the velocity? Velocity is given by 331 plus 0.6 theta. If you consider 15 degrees, what's the velocity of sound? Yeah, we can say 331 plus 0.6 times 15. So you get 0.6 times 16 is how much? Yeah, you get 9. So you get 330 meters per second. Right. The answer here is 9, so you get 340 meters per second. Right. Now you know, if you consider an open pipe, the waveform is like this at the fundamental. If the entire length is L, now let's ignore the end errors, right? If the entire length is L of the pipe, I can say wavelength lambda is equal to twice this length, because lambda divided by 4 times 2, this part is like lambda divided by 4, right? This segment is like lambda divided by 4. So twice of lambda divided by 4 segments is equal to what? The length L. Then I can say lambda is equal to what? 2L. Is that clear? Right. Simply. Alright. So now we know that lambda is equal to 2L. We know the equation velocity is equal to F lambda. So what's velocity? 340. What's the frequency? You have to find it out. What's lambda? 2 times L. So 2 times what? What's the length L? 50 centimeters. In meters, it's what? Half. Therefore, I get the frequency to be 300 hertz. So the frequencies of these two identical open pipes are going to be 300 hertz each. 340 hertz each, I'm sorry. So the frequencies of the two identical open pipes are going to be 340 hertz each. Right. But now what are they going to do? If the temperature of one pipe is raised to 30 degrees, so the temperature of one pipe is raised to 30 degrees, what would be the number of beats produced per second? It's very easy. So now we are raising the temperature to 30 degrees. So look at this. If the temperature is raised to 30 degrees, what can I say? The velocity is equal to 331 plus 0.6 times the temperature, which is 30. Then I get, what's the answer here? I get 18. Therefore, here the answer is 18. Therefore, I get 349 meters per second. The velocity is equal to 349 meters per second. Again, V equals F lambda. Alright, so what's the frequency going to be? We can calculate that because we know lambda. What's lambda here? Again, 1 meter. We found lambda earlier. So lambda is found earlier, so we got that to be 1 meter. So what's the velocity here? We get 349. So frequency is going to be what? 349. I hope you understood. The frequency has become 349. Now, these frequencies are close to each other. 349 and 340 are close to each other. So what's going to happen now? What would be the number of beats produced per second? So when you keep them together, because of the difference in their frequencies, now I'm going to take one open tube and change the temperature of that open tube only. Now there are two identical open tubes. Listen, there are two identical open tubes. I'm not going to change the temperature of one open tube. I'm going to take the other open tube and change its temperature. And I'm going to place them together. When I place them together, I get the difference in frequency. This is what we call as number of beats. So it's a change in frequency, difference in frequency. 349 minus 340, this gives you the beat frequency, which is the number of beats produced per second. So what's the beat frequency then? F beat is equal to what? 9. Right, I hope you understood that. Right, let's come to the 22nd question then. Two blocks A and B of mass 0.5 kg and 1 kg respectively are connected by massless inextensible strings which go over massless smooth pulley as shown in the figure. Which goes over a massless smooth pulley as shown in the figure. The coefficient of dynamic friction between all contact surfaces. Very important, these points, right? These are very critical points. You've got to highlight them. While doing the paper, you can underline them because they say the coefficient of dynamic friction between all contact surfaces is going to be 0.25. What is the force F needed to drag the block B to the left with a constant speed? What can you say? Let's see. Right. I hope you're trying these questions before the discussion. That would be better. Then you can learn a lot, right? It's more effective once you struggle and do the question and then look at the explanation, right? All right. So let's see. Okay, so you're done with this. All right, let's see. So I have the block A and here I have the block B, like so. This is a free body diagram. Right, so it's connected, right? I'm not drawing a pulley, but just marking the tensions. So when I apply a force F like this, I'm asking the system to go like this, right? So when I apply a force like this, I'm asking the system to go like this, go in this direction. Then this block A tries to go here, block B tries to go here, right? When block A tries to go in this direction, it experiences a frictional force in this direction. So the frictional force I can mark on this as F1 here. Because object A is trying to go in this direction, object B experiences a frictional force in this direction. Right? Newton's laws. Newton's third law. F1. Right. And also this tension acts in this direction. And also, because the entire system tries to go in this direction, now the frictional force acts like this. I call it F2. Because when I'm trying to go like this, the entire system acts in this direction. The friction of the entire system acts in this direction. If I just think A and B together, the frictional force acting on this entire system is F2. Is acting from here, from the surface. So there are three forces acting towards the right when you consider B. So this is the tension T. This tension T is equal to this tension T because it's the same strain. Right? What can you say? Now there's a reaction on A because its weight is there. Right? W. What's the weight? The weight of A is 5 newtons because its mass is 0.5 kg. 5 newtons, therefore the reaction should be 5 newtons as well. This weight of 5 newtons is felt on B as well. This 5 newtons is felt on B as well. And also, B has a weight of how much? B alone has a weight of 1 kg. Has a mass of 1 kg, therefore the weight is going to be 10 newtons. Therefore the reaction on B, the total reaction on B is going to be 15 newtons. I hope you understood that. A is pushing down and B is pushing down on this surface. Therefore the surface feels the total weight. Therefore the surface gives you the reaction of the total weight. That is equal to 15 newtons upwards. I hope you understood that. Right, so if you look at B, so B has this 15 newtons upwards, the reaction force. Right, I just draw this separately. If you consider A, so the reaction on A is 5 newtons, right, and the frictional force is acting like this, and the tension is like this, right? And also if you consider B, I'll just draw it here. If you consider B, right, the total reaction on B is going to be 15 newtons. And also we can see the three forces, friction 1 and tension T, friction 2 acting like so, and also the force that I apply F, capital F, right? I hope you understood this question in the first place, right? All right, so first we can find out F1 because we know the reaction. So I can apply F equals mu R for this object, for A. So F equals mu R, what is mu? 104, right, 0.25. So you have the reaction of A to be 5 newtons, therefore I get 1.25 newtons. So F1 is equal to what? 1.25 newtons. This is F1. Right. Can you see, now they have mentioned in the question, right? What have they mentioned? The coefficient of dynamic friction between all surfaces. And also they say, what is the force F needed to drag the block B to the left with a constant speed? So the word constant speed is very important. If the system were to move at a constant speed, if it's to move at a constant speed, what can you say? F1 should be equal to T. F1 should be equal to what? T, because there cannot be a resultant force. For there to be a constant velocity, there cannot be an acceleration. Acceleration is there if there's a resultant force. So there cannot be a resultant force, therefore F1 should be equal to T. I hope you understood that. Right, then what can I say? Tension is also equal to what? 1.25 newtons. So I found F1, I found T. Now I find F2. That's my goal, right? It's very easy. How can I find F2? Again, mu R. What's mu? 104. What's the total reaction on B? Yeah, what's the total reaction on B? 15. Then 15 divided by 4. So you get 15 divided by 4, right? So 15 divided by 4. So we have to add all these three together. What will happen if you add all these three together? Now what's the answer? 15 divided by 4. Yeah? So you know, what's 12 divided by 4? 3. What's 5 divided by 4? You can break it down. So I'm sorry. Okay. 15. I can break down 15 as what? 12 plus 3. Right? 15 can be broken as what? 12 plus 3. Different way of simplification. So 12 divided by 4 is how much? 3. 3 divided by 4 is how much? 0.75. So we get 3.75 as the answer. So it's a method of simplification. Break 15 down as what? 12 plus 3. Divide 12 plus 3 separately by what? 4. Then I get 3.75 newtons. Then 3.75 newtons plus 1.25 newtons is how much? 5. So 5 plus 1.25 newtons is how much? 6.25 newtons. Therefore, the total addition of F1 plus T plus F2 is equal to what? 6.25 newtons. That 6.25 newtons should be equal to what? The force that I apply, which is capital F. Because the sum of forces acting on the right side should be equal to what? The sum of forces acting on the left side. Because there cannot be a resultant force on this object. If there is a resultant force, there cannot be a constant velocity. Therefore, you get F to be equal to what? 6.25 newtons. I hope you understood.